Hey there, welcome back. So we've done the place value model, which is a strategy that helps the kids with understanding conceptually what it is they're doing and why they're doing it, but we don't want the kids to stay there. So we are going to be talking today about a strategy called the explicit trade method, and this is actually a method that is also in your Vanderwall book. So if you have that book, you want to grab that. It is on I use the elementary and the middle school mathematics version of it. You can see it's all beat up and nasty. But Vanderwall has it in all of his editions for pre-K, not pre-K. What am I talking about? For 3-5 and for 6-8 to help students with division. So I wanted to get into that one because I feel like that one is a really good strategy to help kids who are enjoying this method that they're using now with the place value model, because I feel like it's an extension without being overwhelming, because it's literally the same level of thinking, but it is not a lot of where they're drawing a lot of tens and ones, because that's where they get confused and not knowing how many they've drawn, and it just becomes time consuming, and the kids won't want to do it so after a certain time because it's a lot of work. So the strategy that we're going to be doing is called the explicit trade method, and it's in your Vanderwall book. So grab it, take a look at it, and I'm going to use that same problem that we had before when we were working with the place value model, because I want to show the connections between them, because it's crucial that your kids are able to see this. And sometimes you may want the kids to do this if they're having trouble, just to make the connection, because remember, that's what we're all about, is connections, is to see them side by side so they can explain why they're making a trade, and they get why they're doing it, and they're able to apply it without you standing right there next to them. All right, let's try it. So what I've already done is completed that problem that we had last time. So I just left that there. And I'm going to do the explicit trade here on the right side of that. So I want to set it up the same exact way. And that's exactly what the kids need to be able to do. It's the same problem. So thousands, hundreds, tens, and ones. And this was our place value model. And over here is going to be the explicit trade. See the connections there? Trading and place value. Okay. All right. So what we want to do is thinking about what the kids already know. They know about the trades. They know why they're doing them. So now we're going to be moving them to this more efficient method where they are working only with the numerals. And some of the kids may get confused because a lot of them don't know their multiplication facts. And if they are struggling with not knowing the multiplication facts, something that you can have them to do is to write their multiplication facts down the side. So it could be, or if we know that we're using four times something is something, right? So 4 times 1 is equal to 4. 4 times 2 is equal to 8. And then 4 groups of 3 is equal to 12. 4 groups of 4 is equal to 16. 4 groups of 5 is equal to 20. Now, I would have them to do this, but still working on helping them to figure out what those multiplication facts are and how to use them in a smart way, where if they know the 2s, they know the 5s and 10s, then they can figure out anything, okay? Any multiplication fact, they can figure it out. And so if they can figure out the multiplication fact, of course they can figure out the division. So I would work on having them to do that. So this is just a scaffold until they're ready to get there. And so just thinking about this, the questions that we asked when we were doing the place value model would be the same questions that we would ask here. How many groups of 4 hundreds can you make from, how many groups of 4 thousands can you make from only 2 1,000s? Well, they couldn't make any of those. And so what did they have to do here? Well, here they had to cross out the 2,000s and they traded them to the hundreds place. So that's exactly what we're going to do here. We're going to cross out the 2 1,000s, and we're going to make the trade to the hundreds place. And so we had 2,100s. So that's why it's so important that the kids are able to tell you how many hundreds they have after making those trades, because they're going to have to be able to make that connection when they get here. That after they've made the 2000s, traded to the 2000s, now I have 2100s. So now I do the same thing I've done before. How many groups of 400s can I make from 2100s? Well, when I'm looking here, I know that I can make 5 groups. But what is that? How does that translate here? Okay, so just thinking about this. So I'm looking at the kids, okay? We have 1, 2, 3, 4, 5 groups. Why do you think we can make 5 groups here? Well, we're making 5 groups because we have 4 100s in each group. And 4 100s is equivalent to, it's the same as 20 hundreds. So when we take those 20 hundreds that we've divided out already, so basically each television is going to get $500. So that means that we have $100 that we had left that we couldn't divide equally or evenly into those groups. So that's where it comes from. So that's why we have to make a trade. So when we have the 100 down here, what do we have to do? Well, we had to trade it because we couldn't put this 100 equally into those 4 groups. We couldn't divide it among those televisions. So we're going to make the trade up. And so now we have 13 tens. All right, 13 tens. And sometimes the kids may have to count to see if they actually have 13 tens. Because what we don't want is this to be just something else that they memorize. We want them to understand what they're doing so that they'll be able to apply this type of method. So we have 13 tens. Okay, so let's see. 13 tens. How many groups of 4 tens can I make from 13 tens? So let me see. 1, 2, 3. 3 groups of them. So I'm going to put 3, and that is equal to 12. So that means that I am right now 530 about for each television, and I've divided everything that I could divide out in the tens place, but I still have 1 10 remaining. So this is $16 now. So same thing that we had here, $16. And so asking them these questions among what does the process mean is so helpful to the kids. Okay, so same thing. And now we have 16 ones. Well, how many groups of 4 ones can we make from 16 ones? Make 4 of them. And then we have a 0 remainder, which is what we want. We have that 0 remainder there, or something so small that we can't make another group. And that is huge for kids to make that connection. So this is the explicit trade method that a lot of kids are successful with, because it bridges directly from the place value model, and the level of thinking is the same. This can be done with decimals, and this is a strategy that kids have been very successful with. All right, I'm flipping my camera back around. So I hope this strategy helps you with helping kids to make connections, because they can take this question, this type of strategy, and easily take it to the standard algorithm now, which is where the kids need to be when they get into 5th grade with working with the standard algorithm. But if they have these things as a way to build that concept knowledge and to be able to apply the learning themselves, if they can understand these, then they will be fine when they get to decimals, because it's the same level of thinking. So I'll see you next time.